Okay, good afternoon and welcome back. We are going to continue our discussion of distribution system planning. We have a wonderful panel to present a potentially different perspective or amplify the perspective presented by the utilities. Curt Volkmann, he's the president of New Energy Advisors LLC. Jeff Smith, senior program manager, Power System Studies from EPRI, and Samir Succar, senior manager at ICF. Gentlemen, thank you very much for joining us. We're sincerely appreciative. We'll begin with Curt.
Thank you, Mr. Chairman, commissioners, staff. Appreciate the opportunity to be here this afternoon. What I thought I'd do in my opening 20 minutes or so is provide a high-level overview of some research that I've been doing over the last couple months on kind of leading practices, what other states and what other commissions are doing when it comes to the evolution of distribution planning. Some research I did in talking to some of the EDUs here in Ohio to understand how they do things today. We heard a lot of good detail in the panel before lunch. And then ultimately in the kind of the basis for some specific recommendations that I've made as to what some next steps might be in this evolution. Before I begin, I just want to reiterate what others have already said, that when I talk about distributed energy resources, or DER, I think of them in the broadest sense, including energy efficiency, demand response, distributed generation, including wind and solar, CHP, stationary storage, microgrids. All of those I consider to be DER, or distributed energy resources. And I think Ohio is on the threshold of a very significant growth in DER. You heard some of the EDUs mention that earlier, but I think there's some indications that there's going to be some significant growth, and let me just give you a couple of examples. All of the EDUs now have rebates that they're going to offer in their energy efficiency plans for smart thermostats. And if you add them all up, there's the potential for 143,000 smart thermostats across Ohio over the next 3 years. And that's a good thing, because smart thermostats offer not only energy efficiency benefits, but they can also be applied to reduce local peak demands, and I'll explain in a minute how that works. Distributed wind. More and more companies like Whirlpool and Ball Corporation, as shown here in Ohio, are implementing distributed wind on their property to serve the load of their factories or office buildings or whatever to reduce their electricity costs. 2015, Ohio led the country in the installation of distributed wind. The National Renewable Energy Lab, or NREL, says that Ohio is one of 5 states with over 3,000 megawatts of distributed economic potential for distributed wind. Those are installations that would actually pencil out given the current climate. So there's tremendous opportunity for distributed wind growth in Ohio. You've heard a bit about distributed solar, and that there are low penetrations today with fewer than 0.1% of customers with installations. Tough to forecast, but one measure of the potential growth is by looking at what PJM's expectations are for distributed solar's contribution to peak demand reduction. And in the 2018 PJM forecast, they indicated a growth from 69 megawatts this year to 410 megawatts in 2025. So it's a 600% growth in peak load reduction from distributed solar. CHP, Combined Heat and Power, has qualified as an energy efficiency resource in Ohio since 2012. CHP offers, in addition to reducing local load, it can also provide critical infrastructure resiliency and provide continuous electricity and heat and cooling during system outages, so valuable grid services that CHP can provide. There's about 510 megawatts of CHP in Ohio today, and the Department of Energy has identified the technical potential for an additional 7,000 megawatts of CHP. So once again, opportunity for significant growth. And finally, electric vehicles. You'll hear a lot more about this tomorrow in tomorrow's panels on EVs. I did find an AEP study from 2017 that projects between 50,000 and 100,000 plug-in electric vehicles on their system by 2025, which will provide new opportunities to shape load and provide other resources. So the implications of this are twofold. There are more than just these two, but I just want to mention these two. First of all, obviously, there'll be increased complexity on system planning and operations. And again, you heard that before lunch from the EDUs on some of these complications that they're expecting. But more importantly, there's going to be a significant number of new distribution system connected resources, many of which are financed, owned, and operated by customers and third parties. And these provide a tremendous opportunity for them to provide grid services and reduce the need for ratepayer-funded capital investment. And when I say grid services, local grid services, I refer to energy, capacity, reliability, and voltage support as well. It's not just energy. There are many ways to value these grid services, and many states and commissions are struggling with how to value them, but I want to just provide a relatively simple example to illustrate how these, this value could be captured. And this is an approach that's being taken in California, where the value is based on the deferral of actual projects. This slide illustrates the concept where the blue line is the feeder load growth without any distributed resources. The pink line reflects load growth after the contribution from DER, in this case, solar PV. And you see the PV results in the deferral of the need to upgrade the feeder, and the value of that deferral is based on the time value of money for that deferral period. So the longer that this investment in the infrastructure can be deferred, obviously, the more value. And again, it's tied to a specific project at a specific location. So what would this feel like for customers? Well, Nest today offers a program that they call Rush Hour Rewards. And I live in Chicago. I participate in this program as a ComEd customer. And I get $40 a year for participating in the program, which consists of me getting a text message, or actually a screenshot that you see here, and a message on my thermostat the day before an anticipated system load peak. And if I do nothing the following day, during these peak times, Nest ratchets up the temperature of my thermostat in my house to reduce the peak load of my home. I can also choose to opt out the day before if I don't want to participate. That same capability can be applied to address local distribution system peaks. And I've provided an example in the draft paper of how this is done in New York. Central Hudson Gas and Electric has applied technology, not the Nest technology, but they've identified constrained distribution circuits and are deploying the demand reduction capabilities of smart thermostats as well as pool pumps. Customers get compensated an extra $50 to $100 for participating in the program. It's an example of individual customers benefiting and customers overall benefiting from the provision of these local grid services. Imagine if you're a CHP developer or a facility manager that's contemplating installing CHP. And actually, David Owens this morning kind of talked through this scenario, came a couple steps short of where I want to go with it, but he was saying how important it is for utilities to work with customers that are contemplating installation of these resources like CHP. He actually used that example. But what if that CHP developer or customer was also aware that by deploying that CHP, that would reduce the peak demand of the circuit on which that customer is served, thereby potentially deferring a capacity upgrade project. And that value flowed back to that individual customer, which enhanced the economics of the CHP installation, again, providing local grid services, reducing costs for customers overall. So those are just two examples of how these DER resources, if applied at a local, targeted way, can provide grid services and reduce costs overall. But that raises a key question for this commission, a key question that commissions across the country are wrestling with right now, a key question that came up this morning before lunch with the utilities, and that's to what extent is it important to establish an open, competitive market for customers and third parties. I also learned this morning that third party is offensive to some third parties. So apologize if I'm offending somebody. But to what extent will there be a market for others to provide these local grid services in addition to utilities? At least 5 states, Hawaii, California, Nevada, New York, and Rhode Island have said, yes, we want to do this, and have active proceedings underway to change the way that distribution planning is done to allow this to happen. Several other states are in various stages of contemplating what this really means. But if you believe this is important, you believe it's important to open up the market for grid services, then there needs to be some fundamental changes to the way distribution planning is done. And you heard a good overview, again, before lunch on how that process works. This diagram depicts it at a high level. I just want to comment on a few characteristics of today's distribution planning. First, that it's a very closed process. It's the exclusive domain of distribution planning engineers, and there's very little visibility into the assumptions, the data, the analysis, the growth rates, et cetera, that go into the plans, with the exception of rate case hearings. But as you talked about this morning, those are often very contentious, and it's very difficult to get a good dialogue going. There's often a disconnect between the energy efficiency resources that are being deployed, the distributed generation that's being interconnected, and the distribution planners themselves. And typically, those resources aren't explicitly considered in distribution planning at a local level. And finally, the solutions that are considered, the solutions that are applied to address these grid needs, typically have been limited to conventional utility investments. So new substations, new transformers, circuit rebuilds, that kind of stuff. In contrast, these other states and jurisdictions that are transitioning to this new world, which I refer to as integrated distribution planning, builds on the existing approach today, but includes some new capabilities, including explicit consideration of distributed resources in load forecasting, a much tighter integration between the energy efficiency demand response groups, the interconnection groups, and the planners. Beginning to consider hosting capacity, which you heard about already today, and we'll talk more about in the panel here, what that means. The identification and publication of locational value. And locational value is kind of a complementary concept to hosting capacity. Hosting capacity says, where will there be problems if DER interconnects? Locational value analysis says, where will there be benefits if DER is deployed to a particular area? Where can DER provide load relief or voltage support or whatever it might be? So those two analyses are complementary, but both very important. The explicit consideration of non-wires alternatives, so the Nest thermostat example, the CHP deployment, storage, other ways to provide those grid services with non-traditional utility capital investment. The sourcing of those solutions is important. There are different ways that that's done, and I believe Samir is going to talk about that a bit. And then the ongoing management and monitoring of these resources are all things that need to evolve. So as I was thinking about what specific next steps might make sense here in Ohio, I did take the time to interview some of the EDUs and some of the developers that are active in the Ohio market to get a sense of where the parties are today and what might make sense for some next steps. And I'm going to repeat what you already heard today. For the most part, we're experiencing flat to modest load growth in the state, although you also heard there are pockets of load growth that the utilities are needing to address. There is general familiarity, and again, you heard that today, with some of these new advanced planning tools, but they're not yet being adopted or deployed at any scale here in Ohio. And there is limited consideration of DER impacts at the local distribution or circuit level. It's done at a high-level system level, but not at the local distribution level. The developers that I talked to generally said that the responses in the interconnection process have been pretty good so far, a pretty positive experience. However, there are concerns that as volumes increase, there could become increased bottlenecks and delays. There's a bit of a concern there. And without exception, there is very much an interest in increasing the transparency of this information that's available on system characteristics and opportunities for, I want to say third parties again, but to provide grid services and awareness of where these opportunities exist so that these developers can shape solutions to potentially address those grid needs. So given where the EDUs are today and where the other states are going, I've come up with some specific recommendations on what some next steps might be. And these are aligned with the 5 capabilities that I outlined in the draft paper. And I guess my general high-level line is it's premature to leap to the end. There's probably some incremental steps to start with, and that's basically what I want to talk through here. Beginning with the new capability of advanced forecasting and system modeling, I think it's important for there to be a consensus view of future scenarios for customer DER adoption. And I think you heard Kevin Hall say in some of his final comments before lunch that this is hard. This is difficult to do, forecasting where the DER is going to be deployed and where customers are going to adopt it. But I think working together with some tools that exist in the industry and some other expertise, there's ways to come up with a consensus view on where we believe DER is going to be adopted, what by type of DER, an important first step. I also believe, you again heard about this earlier, that given the revisions to the standards, the technical standards for inverters that are going to be published sometime in the next month or two, it's important to readdress the interconnection standards in the state to figure out the best way to apply those functions to fully utilize the value of DER, the DER that involve inverters. As far as hosting capacity goes, I think there's some work that can be done that's often not trivial to define the use cases for hosting capacity. And again, you'll hear more about that from Samir. But this is saying, what are we going to do with the information once we get it? And this is critically important because there are different methods for doing hosted capacity, and they provide different levels of accuracy, and they involve different levels of computational intensity. But if you know up front what you're going to use the information for, you can then determine the most appropriate methodology, the data that's required, the effort that's required, and lay out a timeline for when you begin to start doing hosted capacity over time. So it begins with the use case definition. Similarly, I think it's important to define what's often referred to as suitability criteria for non-wires alternatives. And these are the types of projects that would even qualify. And I would argue it's much more than just capacity-related projects. It could be reliability, it could be voltage. Other types of projects could qualify. But defining that up front, saying these are the types of things that we would consider, we as Ohio, we as the PUCO would consider as non-wires alternatives, and then lay out a potential process and timeline for the EDUs to begin considering these. And that would include the acquisition of the non-wires alternatives. And I would strongly recommend that this be done as part of a collaborative multi-EDU process. And I intentionally refer to this as a technical working group for a couple of reasons. First, when I used the phrase working group in my interviews, I got some groans. And I know there has been some experience with working groups to date in Ohio, and there's been some good and bad coming out of that. But I want to emphasize the technical dimension of this, because this really requires engineering expertise. These are some very technical issues that need to be worked through. So this working group would need to include engineers, not just policy people and attorneys. And I think I heard Tom from First Energy reiterate that point today, saying these are some engineering specific issues that need to be worked through. I also provided in the white paper a potential timeline. I'll just talk through that briefly. I know my time is running out here. I think a very important first step is for this commission to articulate, either as part of the Power Forward process or shortly thereafter, clear objectives and guiding principles for this transition to IDP, or integrated distribution planning. Why do you want to do it? What do you expect to get out of it? What's in it for customers? What are your expectations for the EDUs? The clearer that can be, the less, the smoother the subsequent work can become. I recommend that you require the EDUs, I'm going to get arrows in my back, I can feel it, to file some reports explaining how they do distribution planning today, the tools, the assumptions, the level of DER deployed, the types of questions that I asked in the interviews, which I got some good input, but I was only with them for 30 minutes. And there's a lot more. I just barely scratched the surface. And I think it's important for all stakeholders and all parties in the commission and the staff to understand in more detail how planning is done today. It's going to provide a good understanding of the similarities and differences across the EDUs, and it's going to provide a common understanding of the starting point for each EDU as we transition to this new process. And I will tell you, they will be starting from different places, and that's okay. In the paper, I provide a long list of the types of information that you might want to ask for in these reports, but I think it's important, again, for understanding the starting point. And finally, I mentioned earlier the technical working group. I've proposed a kind of a sequence of activities that group work on, beginning with the common view of DER growth. I explained the importance of that. Followed, or I guess in parallel, the work related to the interconnection process modifications to embrace the capabilities of smart inverters. Having participated in these technical working groups in other states, you don't want to have too many things going on at once, so I purposely have staggered this so you're only dealing with 2 topics at once. So then once that initial work would be finished, you'd start with the non-wires alternative criteria, hosting capacity analysis, and then lastly, talking about data sharing. And I haven't touched on this much, but this new world of transparent planning requires a new level of sharing of system information and capital projects, plans, and all that kind of stuff. And many other states are developing data portals to share this information, and at some point, that's an important topic for this technical group to discuss. So I see my time is up. I will stop there, and I look forward to the Q&A. Thank you.
Thank you, Curt. Jeff?
So my name is Jeff Smith, EPRI. I appreciate the Mr. Chairman, Commissioners, staff. Appreciate the opportunity to speak here today. I'm going to speak a little bit about some of the experiences we've had with EPRI as it relates to various stakeholders across the industry. If you're not familiar with EPRI, we're an independent nonprofit collaborative organization chartered in the 70s for the public benefit. And so we've been working with a lot of different stakeholders throughout the North America, Europe, Asia, as it relates to some of the challenges we're seeing here with regards to integrating DER into distribution planning. So some of the things I'm going to highlight, we've touched on a little bit throughout this morning, and Curt touched on things, a little bit of things today, and I'm sure Samir is going to cover some other stuff as well. But when we think about the integration of DER into planning, we think about it from the standpoint of it's not just planning, it's actually just integrating DER into the grid as it relates to planning and operating the grid. And so I'm going to talk about these things a little bit interchangeably, recognizing that we can't think about planning without actually the end game of actually operating these resources in a holistic manner as it relates to providing, cost-effective, reliable, and affordable and sustainable service for all customers. So when we think about that, what we think about in terms of the integration of DER into distribution planning or distribution operations, there's this spectrum of integration. And we think about it from the standpoint of one end of the spectrum is more accommodating DER, just basically just interconnecting the DER to the distribution system. So that might be customer-based DER, where the customer applies for rooftop solar application, goes through the actual process, the application process, it's approved, customer interconnects the solar system. There may or may not be much interaction with the distribution planner, the distribution operator. As a matter of fact, the distribution engineer may not even know it's there, but it's accommodating that resource. The other end of that spectrum is actually where we're actually looking at DER fully integrated into the distribution system as it relates to planning and operations. So it's actually a participant in how the grid is actually operated. And when we think about those instances like that, that might be where the utility actually has some visibility of the resource, or maybe actually can control some things like smart inverter functions, that sort of thing, that either improves the service that's provided to all customers or increases hosting capacity, or maybe the DER is actually providing services back to the grid, which is mentioned earlier, grid services. So when we think about that spectrum from accommodating to integrating, there are a lot of different permutations and sort of gray areas in between. There's no clear delineation, but the reason I bring this up is because as it relates to this moving from accommodating to integrating, that becomes extremely complex, going from accommodating DER and understanding how it's going to interact to actually utilizing that DER from an operational and planning perspective. And what I would say from this spectrum, the lessons learned from the industry, we're still learning, actually. Even if you're Hawaii or California or New York or Europe, where there's a high level of solar, the industry as a whole is still learning. So as it relates to that, when we think about the maturity of the industry from accommodating to integrating, there's a lot of maturity as it relates to accommodating. There's not a lot of lessons learned that have been developed over the years as it relates to integrating. When I say integrating, It's actually integrating to operations and planning and effectively using that resource in a new way. And so there are demonstration projects that are going on throughout the world. California, New York are experimenting with some of these new planning processes and demonstrations. But again, there's still not a lot happening as it relates to effectively leveraging the lessons learned from that. So I wanted to point that out as it relates to some of these things. So there are obviously some challenges. This is actually challenges as it relates to accommodating, to integrating. So what is the industry doing about some of these, and why are some of these things so challenging? So when we think about that, when we look at the DER and the interaction with the grid, there's certain things that actually had come up earlier this morning as it relates to whether DER can provide benefits to the grid or maybe has an adverse impact, and it can actually do both. But I'm going to kind of unpack that a little bit and talk a little bit more detail on some of those things. So it was mentioned earlier that DER can actually defer infrastructure upgrades, and it can. If DER can provide capacity to the distribution grid when there's a demand for capacity, then sure, then DER can actually potentially defer upgrades. Another potential benefit would be potentially reducing losses. If DER is actually producing power when there's also demand on that distribution system, then yes, of course, losses can be reduced. DER can also improve power quality as it relates to voltage regulation and some of the new standards as it relates to providing voltage regulation capability for DER, so power quality can be improved. So those are all the beneficial things that actually have been brought up this morning. But there are also some adverse impacts that have to be accounted for as well that can potentially occur. The same thing, reducing reliability. So actually DER can actually have interactions with existing protection practices and settings and automation. They can actually potentially reduce reliability. We don't want that to happen, but it's possible. And then of course potentially reducing power quality as it relates to DER integration into a distribution system where it's actually opposing the existing voltage regulation schemes, that sort of thing. And in some cases, DER can actually incur infrastructure upgrade costs depending upon where that DER is located and when that DER is actually providing output to the grid relative to when there's demand on the system, when there's load. And lastly, in some cases, it can actually increase losses depending upon location and time, that sort of thing. So there are two sides of the coin. DER can certainly have a lot of benefits to the grid. There's no doubt about it, well documented. Also, there's potentially adverse impacts to the grid. And a lot of these things are depending on three main factors. One, the DER technology. Two, the DER location. And three, the grid. So the technology, are we talking a solar resource or a distributed wind resource or energy storage or CHP? Or electric vehicles, whatever that resource is, it has a unique characteristic and a footprint it has on the grid. That can be a positive or negative depending upon the other two factors, where that DER is located. In some cases, you can accommodate a lot of DER on a system and actually provide no adverse impact. Other locations, it can actually cause issues or provide value. And to the flip side of that, in other locations where it may not be of value. And then, of course, the grid itself. So this is actually just a map showing the word hosting capacity came up earlier, a map that just shows hosting capacity on an actual distribution system, fairly small footprint. It just shows different distribution feeders, but basically the grid matters. Different grid characteristics, different distribution systems. As it relates to DER and location, all of that matters. So the technology, the actual location, can't say enough of that, and then the actual grid itself. Those are some of the factors that play into the effect that DER would have on the system, whether it's providing beneficial impact or potentially an adverse impact. So why is that so challenging as it relates to distribution? Because some of these things are fairly well known throughout the industry. The challenge that we've seen throughout working across a lot of different utilities is just, for one, the immense scale of distribution. When we think about distribution systems can consist of hundreds to thousands of distribution feeders. It's a little bit different than transmission in that a transmission system is fairly well interconnected. The transmission operator has multiple visible points of different locations on the system, but it's basically just one model. You can think about it that way. Distribution feeders and systems, or you can almost think of them as little microcosms where they're actually just individual systems, and so utilities have hundreds or thousands of these systems on their grid. And so as it relates to that, at the edge of this distribution system, this grid, are where we have millions of customers, and all of them are potential DER customers. And so that creates a new unique challenge as it relates to understanding across a distribution system, because it's huge and it's large, and location matters and the grid matters and that sort of thing. So as it relates to the immensity of grid and the breadth of a distribution system, there's another challenge that was sort of covered a little bit this morning around situational awareness. I heard the words visibility. When we think about a distribution system, I mean, a little graphic sort of illustrates this point. A distribution service territory might be hundreds or thousands of feeders. A planning area, we drill a little bit deeper into that, maybe a couple of hundred feeders. We drill a little bit deeper into that. A distribution substation, we go a little bit deeper to a distribution feeder, and they go a little bit more deeper into like a distribution transformer. It's maybe sitting outside your house, and then you actually the customer. And if you can see on the screen, the visuals get a little bit blurrier as we dig deeper into the distribution system. That's intentional. That's actually reality. The utilities from their planning and operating standpoint have less and less visibility of the distribution grid the deeper you go into the system. And that creates unique challenges because that edge of the grid, that is where we're wanting to connect a lot of the DER, or that's where customers want to connect. So that creates unique challenges from a planning standpoint, but also an operational standpoint. So obviously the models that we're developing, that the utilities are developing, have to improve to provide more granular based results at that level. Well, also we need more visibility in terms of deploying sensors, and AMI can be used to leverage that. But essentially the edge of the grid where we actually are seeing a lot of DER, there's just a lot of unknowns that have to be taken into account. And that's actually creates one of the challenges as it relates to these other things about identifying locations where DER can be located to provide services, whether or not there'll be impacts or not, that sort of thing. So those are some of the things to take into account. So those are challenges. So what are some of the things that the industry is doing to provide solutions to overcome some of these challenges? Two different things I was going to cover. One around standards, and the development of standards, and the other around analytics. So for example, IEEE 1547, if you're familiar with that, new interconnection standard that was just released, was just approved. It's not a new standard. It has actually been around for 18 years or so, but it was recently revised. And this major revision addresses some of the main issues as it relates to improving power quality as it relates to DER and interconnecting DER, voltage ride-through, and then communications. So voltage, basically the main thing around voltage regulation is that when you're interconnecting DER, some of the issues that we see on distribution systems initially are voltage. It's a voltage-based issue. And so some of the things that are specified in the 1547 standard specify means for enabling the DER to actually improve its handshake with the grid to lessen that impact. So essentially it increases hosting capacity potentially. The second one is voltage is ride-through, basically specifying that as we start to rely more and more on DER and less on centralized generation, when events occur on the system, the DER will actually remain online and ride through those events, thus maintaining system-wide reliability rather than tripping offline like they used to in the past. And thirdly, just communications. Some of the conversations earlier came up as it relates to DER management systems and leveraging these DER to provide services. Communication protocols and that sort of thing is obviously essential to moving the industry forward. So that's one area that the industry is moving quickly as it relates to enabling more effective integration of DER. And the second area that has been discussed a little bit this morning is around hosting capacity. So hosting capacity, just to revisit the definition, it's essentially the amount of DER that can be accommodated on the grid without adversely impacting power quality or reliability under existing infrastructure conditions. So various jurisdictions are in various places as it relates to using hosting capacity. Some of the use cases that I believe Samir is going to talk about a little bit later are important to identify. Some of those are around informing developers, enabling planning, and assisting with screening. But essentially, as it relates to using hosting capacity, we think about it from a standpoint of it's some of the benefits around. It enables one to identify where DER can be accommodated without causing any issue, or where DER can be accommodated and it does cause an issue, and what is that issue that needs to be resolved? Is that something that the DER can actually the DER can self-mitigate, or is that something the utility planner can actually change their voltage regulation schemes or whatever that might be to actually accommodate that level of resource? So hosting capacity gives the engineer a visualization of their system as it relates to DER's interaction with the grid. Other issues are around, it provides visibility to the planners and the interconnection engineers from a forecasting standpoint. So if you're looking 2 years out, 3 years out, 4 years out, and you know you're going to see high levels of growth, you can actually identify where you might have limited locations on your system. Maybe it's a certain voltage class that you have of your distribution system, or maybe it's the way the system was designed. You may actually have some issues. And there may be some things that can be done proactively to prevent that before it actually occurs. So there's a number of benefits, and I think Samir is going to talk a little bit about some of those as it relates to hosting. But there are some of the challenges, and two of them I wanted to point out. One is messaging. I glossed over real high level hosting capacity, but it is complex. The analytics and the what it considers and what it doesn't, and how you do it, and the data that you show, it's a complex thing. I've been working with a lot of different utilities and industry stakeholders for the past couple of years, and it's still being figured out as it relates to that. So particularly when you're dealing with customers or stakeholders that are not technical, because it is a highly technical analysis and it's new. Hosting capacity was not something that's been around for 10 years. It's the concept of visualizing hosting capacity and running analysis across a distribution system. That is new to the industry over the past couple of years. And then, of course, modeling. I just wanted to say that because all the hosting capacity analytics are based upon having effective distribution models. And different utilities are in different spaces as it relates to that. In some cases, utilities aren't required to have models for their planning purposes. In some cases, they are. And so different jurisdictions are in different places as it relates to their effectiveness of the modeling. So as it relates to hosting capacity and incorporating that into planning process, one of the things that we did working with the New York utilities, recognizing that there are certain challenges as it relates to implementation of either hosting capacity or just integrating DER, we proposed a staged approach, sort of a walk, jog, run approach. We're recognizing the utilities are in different places as it relates to modeling or their tools, but the end game is where we want to see a full integration of the DER, not just from a hosting standpoint, but actually valuing that DER. And so we propose a staged approach to kind of get there. And as you move from left to right on the graphic on your screen, it grows in complexity, but also effectiveness. So those are some of the things that we identified as an effective approach in this case, and particularly in New York. So to wrap up, I know I'm running a little bit low on time. Planning for DER. Thank you. Planning for DER. There are two main objectives as it relates from a technical basis. One, we want to minimize the impact, minimize that cost, and maximize the value. So maximize the resource. So minimize that adverse impact, maximize that value. And the industry is evolving. It is evolving in a rapid pace from interconnection standards that have just been released or just been approved, IEEE, have yet to be adopted yet in various jurisdictions, but just released. And then the analytics. The analytics are actually moving at a rapid pace as well. Advanced planning tools and methods and that sort of thing. But some of the challenges ahead, obviously modeling of distribution systems, that's going to be an ongoing challenge. Even utilities that have models, because we're looking at the distribution system in this, I heard the term earlier, where we're looking at the multi-flows, or actually, no longer just the one-way flow, the bidirectional flow, but also using the distribution system as a sort of a multi-use tool, right? It's going to require us to model the distribution systems in ways we haven't done in the past. So there's some challenges around that. Then, of course, just leveraging new capabilities. So we have a new standard, a new IEEE standard that enables DER to have a better handshake with the grid. So now we have to figure out how to best utilize that. And so some analytics around that. And then, of course, the grid modernization and how we can leverage things that are actually happening on the grid side in concert with actually DER capabilities to provide this holistic approach for planning and operating the grid. So as it relates to, and the last one was just educating the industry, working with different stakeholders for the past number of years. Education is important because a lot of the things that I'm talking about in here are they are technical issues. It's electrical engineers talking about watts and VARs and amps and frequency and hosting capacity. It is complex, and so communicating that effectively is important and is a challenge. So I'd say recommendations. One of the things that I would say that the state of Ohio is in a unique position in terms of your ability to leverage the lessons learned that are being learned along the way. I wouldn't say the lessons learned that have been done today, because we're still learning. Even in California, even in Hawaii, even in New York, we're still learning. They're actually deploying new integrated distribution planning processes. When we think about And we need to learn from them. But when we think about the planning cycle or the development cycle, from either planning to analyze, to design, develop, to implement and maintain, it's a circle. We're not just, once we define a process, we're not done. We need to define that process, deploy it, learn from it, refine it, and in some cases redefine it based upon what we learn. So yeah, the state of Ohio is in a unique situation because I heard earlier that you have really low, I think I heard from First Energy, 0.1% of customers, so really low levels of DER, but it gives you the opportunity to learn from the other areas that are having high levels of DER and the lessons learned from what they are doing. And in some cases, the process that are deploying now, that may not be what we're doing 5 years from now, because we will develop those lessons learned. So I'll close with that, and and I guess we'll open up for questions at the end. Yeah. Okay. Thanks.
Jeff, thank you very much. Samir.
Great. Thank you very much, Chairman Hawk, commissioners, staff. Thank you very much for the opportunity to offer a few thoughts. Curt and Jeff did a great job sort of setting the stage. And I think we've talked a lot about, the individual components. So I want to step back a little bit and offer a few thoughts in terms of sort of the value proposition. And I'll explain a little bit about what I mean in a moment. So ICF, if you're not familiar, we're a consultancy, about 5,000 folks across the world. I'm part of our energy practice, and in particular work in our DER practice. And so I spent a lot of time thinking about integrated distribution planning. And over the course of this panel and the last panel, we've heard a lot about aspects of scenario analysis, forecasting, non-wires alternatives, locational net benefits analysis, hosting capacity. But I want to take a step back, and not that far back. and in particular, I want to focus on three things. Number one, value proposition. Why are we doing this? And what is the value add for expanding these capabilities, whether it's hosting capacity or locational value, et cetera? Number two, how does this impact customers, right? At the end of the day, we want to understand sort of in terms of the objectives that we talked about this morning, right? How does advanced planning help us get there? And how do we think about that? And number three, as we think about some advanced planning capabilities, what does this imply in terms of the utility role, and in particular, the role of the planning function within the utility? So to get us there, I actually want to start on that last one, which is sort of, what is the traditional role of utility planning? The traditional role of utility planning, can be articulated in a number of ways, and I think we've heard a lot of different versions of that today. I think first and foremost, it's about the identification of system needs in the context of some kind of risk management framework. And so in that context, you hear a lot of sort of different objectives. And we heard these today, which is sort of reliability. We need to keep the lights on. Safety, both for employees and for the public. The physical and cybersecurity of the system, and resilience. And clearly sort of identifying system needs and identifying investments that are sort of cost effective with respect to these objectives gets us to sort of cost effectiveness, and also gets us, if you layer on some of the policy aspects, it also gets to some of the sustainability that's been talked about. And so this is where we've been today. We've been talking about sort of reliability, safety, security, and resilience. And I would argue that some aspects of advanced planning help to further advance some of these objectives, whether it's sort of bottom-up planning, bottom-up forecasting, probabilistic analysis that helps you sort of get at what are the impacts of DER on the system. But I think it's a little bit broader than that. And in particular, sort of what is the pace needed to move forward in terms of integrated distribution planning? So if we're seeing low penetrations of DER on the system, do we need to move quickly? If we've effectively met reliability, resilience, safety, security goals, why should we need to change? And so ICF has been lucky to support the Department of Energy looking at some of the state-of-the-art aspects of integrated distribution planning, working with a number of utilities across the country. And what we've heard time and time again, working with those utilities that are at the forefront, seeing a lot of DER on the system, is that they say, we wish we had started earlier, right? And we'll talk about sort of why and what's the value proposition. But in terms of sort of thinking about what's the value of starting early, it's primarily two things. Number one, addressing issues early is always cheaper than addressing them when they're on your footstep, right? So we heard from Roger this morning that we're at a period where we're expecting exponential change, right? And what we found time and time again is that you end up seeing more change than you anticipate, and that the change comes faster and larger magnitude than what planners had anticipated. And so having a good risk management framework around that is really important, and developing those tools can help you do that, can help you address kind of issues in a proactive way. And second, along the lines of what Jeff mentioned, in terms of sort of getting to that integration piece, it could be that long-term objectives require near-term decisions in terms of investment to drive visibility, to drive controllability, to drive situational awareness. And so from those aspects, it could drive some near-term action, and we have heard from those that are on the front lines that moving early can have a lot of benefits. So with that as a backdrop, I kind of want to return to some of the aspects of integrated distribution planning, and I want to really focus on two aspects here: hosting capacity and locational value. And to start with, I want to focus on hosting capacity. And we heard a lot about what hosting capacity is. I think Curt and Jeff laid it out nicely, and we heard a little bit about this on the last panel. So, with that as a backdrop, and sort of just acknowledging that hosting capacity sort of gives you the amount of DER that a circuit can accommodate, the question is, why do we want to pursue hosting capacity, right? And it could be a number of things. It could be that you want to provide visibility to developers so they know where the lowest cost areas are on the system, and they can sort of leverage their development capital there, right? It could be in the context of interconnection screens and being able to provide more robust analysis so that you can address interconnection applications in a more timely and robust way. That's very different, right? In the one case, you're sort of providing the data publicly. In the other case, you're using that in the context of an interconnection analysis. On the other hand, you could look at not just sort of what are the hosting capacity constraints on the system today as it exists. You could look at sort of where the constraints going to be in 1 year, in 2 years, in 5 years. And if you can do that, then you can sort of anticipate where you're likely to need upgrades to be able to increase the hosting capacity, right? And so there you're in a position of being able to reduce future barriers to DER deployment, and being able to leverage hosting capacity as sort of an advanced planning analytics function. And then you could take, sort of along the lines of what Jeff mentioned, you could take some of these tools up into operations, and now you could start thinking about how you do hosting capacity in a more dynamic way. So now you're able to sort of look at dispatch feasibility analysis, and if you have an aggregation of DER that want to provide services to the distribution system or to the bulk system, then these kinds of planning capabilities now are in a position of being able to facilitate the provision of DER services. So depending what the outcomes are, what the value is of hosting capacity, it's going to determine what the approach is. But having a good sense of what you want to get out of these tools is essential. So going back to sort of what's the role of the utility planning function, now in the context of these new use cases, I think this world expands, because now we're not just looking at reliability, safety, security, and resilience. Now we're looking potentially at enabling market participation. That's a role that the utility planning function hasn't historically had. Streamlining interconnection, certainly that's an aspect of the utility role, but now we're sort of leveraging advanced planning tools to help facilitate interconnection in new ways. Proactive DER integration. Now this is actually not only a different role, but I think a different paradigm for utility planning. This requires utilities, and Lee mentioned on the last panel, right, that the focus has been on sort of meeting the capacity needed to meet peak. This is identifying investments needed to integrate DER. That's very different, right? That's a different paradigm. But it's an option, and it's something that one could pursue if you wanted to leverage hosting capacity analysis in this way. And finally, sort of facilitating distribution services. And this gets on the point that Curt made, which is now we're getting into some of the value piece, right? And this gets really to the essential piece of why distribution planning is so important in the context of Power Forward. If distribution planning is essentially about identifying system needs, then, you know, that is sort of, you know, gives you the value by which you can put a price on DER services, right? So Sayan talked about infrastructure optimization, but planning gives you the costs you're minimizing and the value you are maximizing to facilitate that optimization. So talking about value, we've talked about these in a number of different ways. Tom from AEP was talking about pancaking value much in the way that I'm sort of showing here in terms of different types of locational value. These are sort of some of the same flavor of what Jeff mentioned and what Curt mentioned in terms of sort of distribution capacity, O&M, the potential of thinking about increasing hosting capacity as a locational value, reliability, resilience, reduced distribution losses, and then similar sort of locational values on the transmission, generation, environmental, societal level. But then it's also a question of sort of how do you want to implement this? Do you want to implement this in the case of procurement, programs, or pricing? And that has different implications for how you go about this. So if you're thinking about procurement, and this is largely kind of that T&D deferral that Curt showed in terms of sort of deferring the need for traditional T&D investment. Now, this could go beyond just deferral, right? You could actually look at sort of integrating DER into the planning tool set. So now you're not just sort of identifying a need, coming up with a traditional solution, and then identifying if DER can defer that need, but also you could also look at approaches to actually reflecting the value of DER in the planning process itself. That's very new, but that's an approach that one could take. Second is in the context of programs. So utilities already do a lot to deploy DER on the system, primarily energy efficiency and demand response. Now, if you could quantify the system impact of those programs, you could target those programs, and by doing that, you could enhance the system value those programs provide. And that's incredibly powerful because those programs are already at scale. They're already out there, and now you're sort of thinking about ways to leverage these tools to improve those programs. But it requires a collaboration between planning and program design that historically hasn't happened, but we're starting to see that happen now. And finally, on the topic of pricing, and you're going to talk a little bit about distribution markets on other days and other weeks, but this is a way that you could sort of leverage frameworks for locational benefits to think about kind of price formation mechanisms in the context of retail price tariffs and retail rate design. And so this adds, two new layers of sort of maximizing the system value of programs and integration of non-wires solutions into planning, either as T&D deferral or is kind of an inherent way of making DER sort of part of the planning tool set. So going back to my original 3, the value proposition is really about use cases. If you can understand the use cases and you can understand sort of the value that you want to get out of these tools, that's extremely powerful, because then you're framing the discussion in terms of outcomes, not in terms of methods, not in terms of tools, not in terms of data, not in terms of portals, in terms of outcomes. And that's incredibly important. And that is also important because ultimately the impact to customers depends on those use cases. In some cases, you're thinking about, how am I going to put information in the public sphere to inform development? In some cases, you're thinking about, how am I going to enable distribution services? Understanding those outcomes is going to frame what the customer value proposition is for expanding these capabilities. And finally, this really requires thinking about the utility role in a very different way, right? So, if you really want to make DER part of the planning tool set, it means you have to have a very clear linkage between the DER performance characteristics and operational aspects and your utility system planning criteria. If you don't have a clear line of sight between those 2 points, you can't make DER part of the planning process, right? So, and Curt mentioned sort of non-wire suitability criteria, which is sort of the first step along that road, which is, if I have a traditional investment, how do I sort of think about opportunity for deferral? If you want to sort of continue down that road, you really have to have a clear sense of how you're going to use DER in the context of providing those system benefits. So with that, thank you very much.
Samir, thank you. We will again begin with questions from the staff. Kishan?
Yes.
Go ahead.
I'll ask a question. I think it was Curt who identified the issue of the disclosure of the grid needs, and we're having that issue, at least on the transmission side, where you disclosing critical load or disclosing market sensitive load may not be something that we want to share with the entire world. So how do you deal with disclosing critical need, for example, on the distribution side now? We're on the distribution side, and we have a critical load that is, there's going to be growth in this area, but it is could be homeland security issue, for example, or it could be like the utilities mentioned earlier today. It could be a manufacturing facility or a competitive, or has some competitive aspect to it that they don't want to disclose. How do you collaborate and make it an open process for that specific example?
Yeah, maybe the best way to answer that is by giving you some examples of how this is being disclosed in other states without violating customer privacy, without jeopardizing security. And if you think about the planning process we've been discussing, ultimately it comes down to a period of time at which a circuit is unable to provide what it needs to. It could be capacity, it could be voltage or whatever. Utilities can articulate that by saying, we need 1 megawatt of load relief between the hours of 4 p.m. and 9 p.m. up to 10 days a month in the month of August, with the probability of that occurring to be X, and we could need it for X multiple times a month, and we need it for a 5-year period. And with that level of detail, I'm probably forgetting a few more dimensions, with that level of detail, a DER developer can shape some solutions that could potentially address that need. So it doesn't need to get into the specifics of an individual customer that's driving that need, but by describing the need itself, and I gave you a capacity one, but again, there are others, it opens the opportunity for developers to respond to that need and provide alternative solutions. You want to pile on? I thought you were going for your mic, sorry. Does that answer your question?
Christina?
Jeff, I believe you kind of specifically addressed the updates to the IEEE 1547 standard. Could you just elaborate a little bit? You described enhanced communications capability, kind of what that means.
Yeah, so basically specifies different protocols that the DER must provide. One of a couple of options, DNP3, Modbus, Sunspec Alliance, some of the different protocols that are available, many of which DER providers have the capability to do now, but it allows the standardization of the protocols so that when the DER has certain capabilities and these protocols can be called upon and leveraged within existing distribution assets and communication, the distribution side communication protocols, so that handshake can actually be handled in a standardized manner. So rather than one communication protocol being connected to a distribution system that utilizes another different communication protocol. So allows that handshake to occur. And there are a couple different options, but it standardizes that, which enables, like, for example, smart inverter functions to be dispatched or to be changed over time based upon grid needs as the distribution system changes over time.
Yeah, go ahead, please.
Maybe that's a question for Samir. Have you seen any studies on that value proposition you were talking about? Like, I've seen it on a RTO level, for example. This is how much savings you get by sharing reserves instead of building more generation, or on the sharing of frequency or regulation, ancillary services, how they can demonstrate a value.
Right.
Have we seen with other states any financial studies on savings, net savings from deploying DER instead of building a substation?
Yeah, absolutely. And so this is frequently done in the context of non-wires alternatives solicitation. So whether it's National Grid's Baldwinsville non-wires, ONR's Pomona, I think the most frequently cited one is probably Con Ed's Brooklyn Queen Demand Management project. In New York, there's a established framework for a BCA, benefit cost analysis, that specifies a set of criteria which determines sort of whether those non-wires alternatives pencil out with regard to the traditional investment. In the context of California, locational net benefits analysis is kind of the equivalent, and that framework is still being fleshed out in terms of how it's going to be implemented with respect to DER solutions. But there's a number of different frameworks for doing this. I think it's still an open question on how this is going to ultimately be implemented once non-wire solutions become more than just kind of an ad hoc solution as opposed to a more routine part of the planning process. So we're still very early days, and we've seen some early examples of how utilities can evaluate some of these DER portfolios to assess their relative benefits and costs with respect to traditional solutions, but I would say that those efforts are still at an early stage.
Howard? Okay. Tom?
I wanted to just follow up on this, on the, the meaningful stakeholder engagement and internal collaboration, the technical working group that Curt, you have mentioned. And, we've had, and we have, some meetings in regards to technical, and I think we have an ongoing group that meets, probably not regularly, or at least there's time periods when it doesn't meet, and then, they get together. They're technical people. They're not really policy people at all. I just wanted you to talk a little bit more about You mentioned other states. So I don't think Ohio would fall into that category, but that would have something exactly what you're talking about. But do you want to say anything more about it?
Sure, and again, maybe I'll describe an example specific to California where I've been participating in the locational net benefits analysis that was mentioned earlier, and the hosting capacity analysis. They call it an integration capacity analysis working group, and it's been close to a 2-year process now. But a couple of things that I think make it work well. It's far from perfect, but it is getting results. There's a clear mandate from the commission as to what the expectations are by when. And the commission has actually laid out topics for consideration or questions that need to be answered by the working group. There is an external facilitator that has expertise in this area, that keeps the process moving forward, that documents the points of consensus, but also points of disagreement, and is responsible for authoring the working group final report that goes back to the commission. The commission considers the recommendations, the consensus view, non-consensus view, makes a ruling, comes back with another set of questions that the working groups need to address. And it has a pace to it that, even though it's resource intensive, it's leading to results and outcomes that were originally articulated by the commission at the beginning. It's an open process. Anybody can participate. I will say at the very beginning there were lots of stakeholders involved, but quickly attrition kicked in. And now it's really a dedicated group of people that have formed new relationships, frankly, and trust each other in a way that didn't exist when the whole thing started. All the utilities participate. All the utilities send their engineers to participate at once, because there is a desire to have a common approach across the state of California. Clearly that can't apply always, but at least exploring the opportunity to do it the same way across all the EDUs, I think, is important for clarity, consistency, simplicity. Lots of reasons you want a developer operating in Ohio to expect one thing or the same thing from each of the EDUs they interact with. So those are some of the characteristics, and my understanding of there was a market development working group in Ohio that I heard about. I don't know the details of it, and I guess it worked well as I understand it, but it was a real long, drawn-out process. And to contrast what I just described at California, I would encourage you to have, first of all, clear expectations up front as to what you want out of it, and then a clear timeline and expectations for when answers to your questions should be provided by the working group. But ultimately, it's the commission that rules on the decisions, answers the questions. It's not the working group. The working group makes recommendations that come back to you.
Okay, very good. Good time? Okay. Question for everybody, but I want to point to Curt's slides in particular, and slide 14 and slide 15. So slide 14 to me represents conceptually distribution planning as it exists today, and slide 15 is integrated distribution system planning, potentially new or enhanced functions for this grid mod world. Okay.
Right.
Question one is, how prescriptive should we be with distribution utilities associated with the planning process, whether it's getting as into the weeds as the type of modeling that should be utilized, or even as broadly prescriptive as something like is visible here on slide 15?
I would say initially not overly prescriptive, and that is why I recommended that there be an exploratory stage in the form of requiring these reports for the commission and all stakeholders and staff to better understand really how it's done today. We heard about it in a 2-hour panel this morning. I heard about it in a series of 30-minute interviews. It's complex.
Yeah.
But by beginning to understand the details of how each EDU does it today, then we will reveal where there are significant differences, where there's similarities, where there may be an opportunity to have everybody get on the same page and do it the same way. And at that point, you may need to be prescriptive and say, you've been doing it one way for the last 10 years. It's important for us and stakeholders to change the way you do it. But it begins with an understanding of the starting point. And I think some of the other recommendations that I made under the technical working group is to, again, build a consensus view of how much and how fast some of these new capabilities need to be implemented. You may conclude, for example, that because of the low levels of penetration of distributed generation, there's not a need to do a detailed hosting capacity analysis for several more years. But this technical working group should analyze that and understand it and base it on forecasts of growth and some of the other stuff that precedes it. So I would say initially, don't leap to conclusions and be prescriptive. Spend the next period of time exploring and learning about more about how it's done today.
Any other comments on that question?
Yeah, I might chime in there a little
Go
bit.
ahead, please.
So I actually agree with what Curt said as it relates to understanding kind of where different utilities are in their current planning process and the tools and methods and data they have available. And I would second what you're saying in terms of maybe go a little bit more detail in terms of maybe as it relates to focusing on the outcome, what the objective is, not necessarily as much the process, because I think the process is going to evolve over time. I think what we're seeing in Hawaii and California and other places, the IDP, this integrated distribution planning process, there are proposed methods and there are things that we're stretching, we're flexing this method now. Being prescriptive might lock us in and actually may eliminate the ability to actually be a little more flexible as it relates to specific needs or specific growths that we see with different either technologies in Ohio or whatever that might be. But I would say focusing on kind of where we are now and where we want to be, and then let some of the details work themselves out over time, because I do think time is something we have at least on our hand, on our side in this space. Because the IDP and I do like the flow diagram that Curt's showing here, but the details are still being refined and redefined in different jurisdictions based upon lessons learned.
Yeah, I think that's exactly right. And I think giving utilities enough space to innovate is essential, because these methods are evolving, because these techniques are continuing to evolve over time, and locking into a sort of prescriptive path forward, I don't think is going to result in the best outcomes. I think identifying outcomes and then letting the utility sort of innovate how best to reach those outcomes tends to be the best path forward. And I agree wholeheartedly with what Jeff said in terms of sort of understanding, having good sense of the baseline, and what Curt is suggesting in terms of kind of an exploratory path initially helps to do that, because this isn't a realm where you can apply the same solutions everywhere. Utilities have been engaging successfully in load forecasting for decades, and knowing how to expand those capabilities is going to be need to be tailored case by case.
Let's unpack the concept of the marketplace a little bit as we're discussing distribution system planning. So when we're talking about, quote, the marketplace, are we talking about primarily, at least right now, the non-wires alternatives marketplace? Is that the marketplace that we're talking about? So let's just park, behind the meter solutions right now. So when we're talking about the marketplace, is that what you guys are referring to?
Yes, that in the sense of distributed resources providing grid services as an alternative to conventional utility investment. That's what I'm referring to.
Okay.
I think that's largely true. I think that's where efforts are focused today. But I think there's a broader point that any notion of cost and value sort of stem in one way or another from the planning process and the identification of system needs. And so whether that's being applied today in the context of non-wires alternatives, or if that's being applied in another context down the road, I think fundamentally sort of being able to understand what are the costs of DER integration, being able to accurately reflect their impact on the system, positive and negative, is going to be essential for any type of either procurement mechanism like non-wires or any pricing mechanism or other type of market.
Beth, go ahead, please. Thank you.
I just have two quick questions. One is, I think, Jeff, you brought up grid edge. Could you give me a definition? I know that, I kind of know what you mean, and I know you had a definition of hosting capacity, so I just wanted to make sure that I was clear on what you meant by that.
Well, I would say that grid edge is different from different jurisdictions. It's really just a concept that towards the end of the grid, so basically, distribution systems are for the most part, I'd say 99%, 99.9% radial. They're not networked, so they're not. It's not like the transmission systems where you have an interconnected grid where you have different cities connected to other cities, and you can open and close tie points and so forth, tie lines, and actually still serving customers. The distribution system, for the most part, is what we think about it. Sort of an analogy is it's the roads that connect us to our homes. For the most part, one-way streets or limited traffic flow. There's only one way in or out of a neighborhood, kind of thing. And so it's that edge. It's where the end of the grid. So that might be at the low voltage level, but that might actually be at the medium voltage level at the end of a long three-phase line. But it's just the edge. It's the perimeter of the grid, and that's where a lot of for example, distributed wind, that's where we see a lot of distributed wind connecting because that's where there's land. And we see the same thing with solar as well, because that's where there's actually typically cheaper land, or maybe there's some rooftop space, that sort of thing. But it's the perimeter, basically, of the distribution system.
Okay.
Does that answer the question?
Yeah, it does. And Samir, I was wondering, you had mentioned in your comments that utilities shouldn't wait for integrated distribution planning, that it's easier to do it now and less costly than waiting till it's on your doorstep, I think you said. So could you put some detail around that? Like, what is the tipping point? What kinds of things should they be doing now that maybe they aren't doing? I guess I just wanted more information about what you meant.
Right, and I think Jeff touched on this a little bit too, which is developing some of the circuit models can be hugely beneficial just in terms of understanding the current state of the system. A lot of utilities might not have circuit models for their entire distribution system. Some might only have it sort of in isolated places where they might have significant load growth. So just the exercise of sort of having a better understanding of the system helps utilities to better capture the full range of outcomes that could unfold, and prepare for scenarios of high DER growth that they might not be anticipated as sort of their quote-unquote base case, but might be part of a set of scenarios that could be plausible given different technology, policy, economic outcomes. And so from that point of view, it's important to maybe not move to full deployment of DERMS, if there are no DER to control, right? But doing some analysis, understanding where you might start to see issues like secondary voltage rise, which might come at the grid edge, could be hugely beneficial in terms of sort of seeing those issues before they arise and being able to start to address how to mitigate them proactively.
Others? Dan?
This is to any and all of you. The question is addressed to any and all of you. If we were to decide that it made sense to pursue integrated distribution planning to encourage it or compel it, would it make sense to do it in two steps, essentially? And I kind of am keying off of your description, Jeff, of accommodating versus integrating DERS or DERS. And I'm also kind of keying off of your slide 28, Curt. Would it make sense to start with the inventory of what's being done out there by the utilities and have them report on it? And then first step, working on figuring out how to accommodate DERS, DERS first, and knowing that we have relatively low penetration levels and magnitudes of DERS in Ohio right now, not necessarily try to eat the whole enchilada all at once, but rather would it make sense to focus on the accommodation issue as a practical matter first and think about the integration issue more deeply before actually trying to handle it? Or does that not make sense?
That's what we've seen. It seems to be effective in New York as it relates to understanding the accommodation of DER and using different metrics to understand to give the engineer and potentially in their case in New York, the public, a sense of where DER can be more easily accommodated with the end game of fully integrating it and working towards that as a multi-step process. I think that makes sense. We see when we think about integrating DER or working with various stakeholders, the first thing is the accommodation. It's the hosting. It's how much can you accommodate where, and what potential issues will I see, and how much will it cost to interconnect. And then that second stage is around integrating DER into operations and leveraging the resources and using it as a non-wires alternative. And with the load growth that I heard earlier this morning, and I think Curt mentioned as well, the load growth in Ohio are pretty typical around what we see around the U.S., fairly flat, a little bit of growth in certain places, but for the most part flat. And as it relates to non-wires alternative and DER as a non-wires solution, it can be difficult to locate DER to provide grid services when there's just not a lot of load growth. There's some, I think recently in California they've had some where they've been exercising the LNBA, the locational net benefit analysis, and they were looking for better locations for DER to provide grid services. And I think because of the load growth, low load growth, there weren't a lot of constraints. So if there's no constraint, grid services, it's hard to find, it's hard to stack those value streams as it relates to DER. So as it relates to low load growth here in the area and low penetration of DER, accommodation seems to make sense first, and then working your way towards integration. And as we see things like electrification, electric vehicles take off, some of those things, I think some of the more opportunities will arise for like non-wire solutions, and using DER in that sense as it relates to integrating DER. So.
Yeah, I think it makes absolute sense to not bite off the whole enchilada at this stage, and that's why I took a shot at page 28 to show kind of a staged approach to this and answer some upfront questions that I think are important and will dictate the scope and scale of work down the road. Just to highlight again the growth scenario, a shared understanding of where you really expect to see these resources in areas and by customer adoption rates too, so which individual customer types are likely to adopt them, and getting a common vision across the state of where we see that's going to drive a lot of additional work. And this smart inverter, IEEE 1547, very techie thingy, it's important. It's really important. It's a fundamental change in the way these resources can be utilized. The new standard will be published in April. Mm-hmm. But the new standard says it's up to the commissions to determine how to use these new capabilities. So it quickly becomes an issue that you're going to have to deal with, an opportunity that you have the opportunity to deal with, because once you revise your interconnection standards to appropriately take advantage of these new capabilities, that unlocks a whole bunch of new resources. My final comment, and I'll shut up. I again want to reiterate the importance of this commission establishing some guiding principles and objectives up front before anything gets started, because the states that I've worked in where that's been absent has resulted in a lot of floundering. The states that I've worked in where there's been clarity on the commission's expectations have run a lot more smoothly. So I strongly recommend that be part of your process as well.
And And I would just add, I think it makes a lot of sense to have some near-term objectives, but I would frame those as iterative rather than a phased approach, in that you're building on what you can accomplish at each stage and sort of leverage that into the next stage, number one. And number two, sort of launch into the process with a very clear sense of where you want to end up, so that if you want to be able to quantify certain distribution values, to be able to provide the kind of infrastructure optimization that Sayun talked about this morning, that sort of plays into a clear sense of what that means for visibility, controllability, situational awareness, and some of the communications infrastructure needed to facilitate that the quantification of that value, right? Because I think those long-term objectives might have near-term implications.
Any other questions?
Just
Howard,
one-
go ahead.
Just to follow up on that, the commission now certifies, the commission now certifies renewable energy projects, and it's easy to see who comes up. Someone puts a solar panel on their house. A company puts in a combined heat and power project. I mean, those are sort of fed from within, if you will. It's usually it's going to be the hosting entity that comes forward, gets a certificate, and I understand how it's important now to integrate that into our planning. I guess where I'm sort of missing it is that if we find that there's a deficiency on the edge of the line, are there developers who would come in? I mean, I know that the homeowner isn't going to go put a solar panel on someone else's house because it happens to be on the edge, or a company develop combined heat and power for someone else. Are there developers who would come in and fill that gap on the edge, or well, anyway, just leave it there. Does that occur in other jurisdictions?
In terms of the system upgrades needed to interconnect that system,
Yeah.
well, I don't know the details in Ohio, but typically an interconnection application would be filed, and then upgrades would be identified, and the utility would typically undertake those upgrades needed to interconnect that system.
No, I was looking more like on your examples before, like in Brooklyn, where the Con Ed said, gee, we could put a substation in here, but it's so expensive to put a substation in here because of the land,
Right.
so we'll put a battery in, or we'll put another alternative in. Are there developers who step forward with that other than the utility?
Absolutely. The BQDM had an auction process where they solicited bids from third parties, and evaluated those bids in an auction process. And there's a potential to sort of pre-register solutions to sort of speed up the process of actually being able to implement non-wires solutions. So. There's different ways to approach it, but yeah, absolutely, that would be kind of a third-party role.
Okay, well, that answers my question. Mechanically, then, if the utility identifies that here's our edge and here's an area where we need some support, the one of the tools is to have an auction and just see what comes forward.
Yeah, right.
Thank you.
Commissioner Friedman.
Yeah, just quickly, I'd just solicit a generalized opinion. This morning, Sayun talked about the tendency to build additional lanes on the 26-lane expressway. If the load forecasts were demonstrating a more exponential or notable growth in load anticipation, we may be tempted to do that. But with the flat load forecasts, is this not an opportune time to let the marketplace evolve as it relates to DER?
I think it's a great opportunity. And I did hear, too, that even though overall system growth is relatively flat to modest, there are, in fact, pockets of growth that could require capacity upgrades that could be candidates for what we've been talking about. So I think it's a good opportunity to test capacity-related non-wires alternatives, voltage, reliability, and you've got time. You've got time to do it thoughtfully. which I think is great.
I think that I'd second that as it relates to demonstrating these types of technologies to provide those services. That's one thing that the industry is still trying to develop lessons learned around as it relates to having a constraint or having 2 lanes of traffic and needing 4, and leveraging DER and its capabilities. There's lessons learned that can be developed as it relates to that in sort of a pilot stage kind of thing. But it all goes down to if you may have 14 lanes of traffic or whatever that was, but if you don't have a lot of congestion there, then you may or may not need another alternative. But it does give you some time, to your point, to develop demonstration projects and pilot projects to test things and to flex these new technologies as it relates to the grid needs and develop further lessons learned.
Sorry, one more question. So if we are not to be overly prescriptive with utilities with respect to their distribution system planning, is there an area where it's important to have uniformity across the 4 distribution utilities?
Hosting capacity comes to mind, that you really want to have a common set of use cases defined so that everybody's thinking about this the same way. Ideally, everybody's using the same methodology, everybody has the same data requirements. Just makes it easier for the market to work if there's a common approach. Similarly, if you get to the world of defining locational value and rewarding developers for participating in providing grid services, the way that's calculated should definitely be the same across the EDU. So you want to have, think of a customer or developer seeking to provide services across the state. To the extent that that's consistent and they know what to expect, it just makes the market work that much better.
Very good. Any other questions? Yeah, go ahead.
Sorry, I can't help myself. So to follow up on the chairman's question earlier about, again, the reporting, right now utilities file with us by law their demand forecast, plans to satisfy the demand, schematic diagrams where the growth is, and as our chief analyst said, DG, distributed generation, we know exactly the location of these distributed generators behind the meter. So the question is, so we have all that information, so that's our base case, or whatever you folks referred to earlier as the base case. Is there another reporting that's a bit better for states that have more DER right now, like in California? Do they have these filing requirements on their electric utilities to file annually, or no one has that requirement except in Ohio? I mean, in Ohio we have a mandate on all utilities that distribute electricity to more than 15,000 customers. So we have a large set of rules that everyone follows. Are there other examples that are more advanced than us? Thank you.
Yeah, and again, maybe I'll just give an example. So done some work in Minnesota, and there are utilities with very different sizes in Minnesota, and the Minnesota Commission 2 years ago maybe required them to go beyond the describing what historically had been provided as part of regulatory proceedings in terms of what their capital investments are, budgets, all that kind of stuff, and get into the details of how they determine those projects. That is, explain in detail how you do distribution planning today. So it's, even though the outputs of that process may be in the public domain, and you may get annual reports of what they're expecting, and I apologize, I'm not deeply familiar with those reports, but I suspect the details on the inputs and the assumptions and the calculations that led up to those outputs might not be as public. If they are, great. No need for these additional reports. But I think there's a level of additional transparency that all stakeholders could benefit from if it doesn't exist today.
Please, sorry, go ahead.
I would just add that I think it's an important question in terms of what's the rationale for providing the information, and that can help to shape the specific data that's provided. And I think that's one case in which stakeholder engagement working groups can be really helpful. And so to the extent that there's detailed load curves being provided to help to inform, for example, energy storage development use case, that could be one requirement. If it's to help understand sort of risk management of the utility to sort of meet its requirements, that could be a different requirement. And if it's developers wanting to work with the utilities to help identify system data that could be beneficial to developers to address some of the issues you raised earlier in terms of perhaps sensitive loads or security issues. Looking at not just sort of what's the data that's being provided, but what's the information that's being conveyed. And the difference there is sort of, data is just numbers, but information sort of gives you meaning. And so how do we provide the information without maybe sort of exposing the data? I think the kind of stakeholder engagement technical working groups have been really helpful in sort of sorting through those issues. So I think the answer to your question kind of depends on what the purpose is for that data, and I think you can tailor the approach accordingly.
Please give our panel a big round of applause. Okay, it's 3:42. We will take an 8-minute break. Back at 3:50.